Assalamualaikum and hello to everyone. My name is Hazami. This is my group member Muhammad Daniel, Ahmad Zahirul Haq, Abdul Hazim and Muhammad Shahid. We are from group 1 and want to present about heat conduction. Next. For the introduction, heat conduction is the movement of energy from substance more active particles to its neighboring less energetic ones as consequence of particle interaction. It is a transition of energy and entropy between neighboring molecules. The heat conduction occurs in solids, liquids, and gases, and it is attributable to the interaction of diffusion of molecule during the spontaneous movement. The integration of motions of molecule in a lattice and energy transfer by free electrons causes this in solids. The intensity of heat conduction through a substance is determined by the medium structure, width, and content, as well as the temperature gradient across the medium. Next. Consider a steady state of heat transfer through the wall of an outer with thickness delta X, where wall within the outer is higher temperature, contrast to the outside wall. Heat transfer occurs in X direction and is perpendicular to the temperature differential axis. Heat transfer is determined by the higher and lower temperature of outer wall, as well as the geometry and condition of the outer. And this is the equation for the calculation. And thermal conductivity is, which is K, is transport property in equation 1. A is the outer across section region and X is the width of the outer wall. Equation 2 reduces to Fourier's law of conduction in the limiting case of delta X. According to the second law of thermodynamics, the temperature gradient delta T over delta X must be negative. The objective of this experiment is to investigate the Fourier's law for linear conduction heat along a homogeneous bar. Next is to examine the temperature profile and determine the rate of heat transfer resulting from radial conduction through the wall of a cylinder. Next, I will pass to Ahmad Daniel.
So for this experiment, we use the unit assembly for heat conduction model HE105. Next. It consists of control panel, heater power indicator, heater power regulator, temperature indicator and selector, thermocouple connectors, thermocouples, radial module, and linear module. Next.
Okay, next is experiment procedure. This procedure was for linear module. First, we make sure the machine was switched off, and next, 25mm of stainless steel specimen was inserted to the linear module. Then the main power switch was turned on, and next the heater switch also turned on to supply heat. And after that, the heater power will be controlled and wait until it reaches 5 watt value. Then the temperature for all 6 locations was recorded, and for each location 3 times data was recorded. Then the heater power was increased to 10 watt, and repeat the step 5 for record the data. And then lastly, step 1 until 6 was repeated for 25mm brass specimen. That's all for me.
Okay, Assalamualaikum. Next is data analysis. My name is Abdul Aziz. And so this is the data for our experiment, which is you can see from different specimen, which is this 25mm stainless steel, 35mm brass, 35mm stainless steel, and okay, so this is the graph we get from our data. So next, I pass to Shahid.
Assalamualaikum. I'm going to explain about the discussion for this lab. Firstly, the temperature at power 10 watt for brass form measuring point from point T1 to point T9 shows that the temperature decrease when distant from the heater. Next, this happened due to the heat coefficient has no longer enough energy to constantly heat up the material per meter of degree Celsius through conduction. Next is energy supply to the material increase, the thermal conductivity value also increase. Next. From the calculation, we acknowledge that the thermal conductivity of 25 millimeter brass is 186.58 watt meter per degree Celsius. At 5 watt is 377.28 watt meter per degree Celsius, and 551.66 watt meter per degree Celsius for 25 stainless steel at 10 watt and 15 watt respectively. This shows that the higher power will provide higher thermal conductivity for 1 meter to increase 1 degree Celsius. Higher temperature will be obtained where it will increase the thermal conductivity of the element, and the greater the power, the higher the temperature to be generated at the heater section. Next is linear temperature distribution of the brass and steel element with the same power, comparing interchange center section with the brass and steel respectively with the same higher power. Homogeneous bar has constant heat transfer rate from section to section with almost equal temperature difference between point where there is different rate of heat transfer from section to section for composite bar. The reason is that the brass has higher thermal conductivity than that of stainless steel, which affect the temperature distribution through that element. Both linear and radial conduction exhibit different graph characteristics when comparing the same material of brass and the same highest point, which are referred to as linear graph and inverse of exponential graph respectively. In linear heat conduction, the mass of metal being heated increase linearly with distance, whereas the radial conduction, the mass of metal being heated increase report with the distance throughout radial module. The temperature at each measuring point is lower than the linear module because heat generated is distributed at increased radius with small temperature difference. Next is conclusion for this report is, so from the experiment result we obtained, it can be concluded that the distance of the material from heat source play roles in heat change, where the higher the temperature can be gained by particular material by locating it near to the heat source. From the experiment, thermal conduction occurs on a higher temperature to a lower temperature. And from the two materials, the thermal conductivity for brass is higher compared to steel material based on the calculation made. In radial flow of heat, we can conclude that the brass has higher thermal conductivity than steel, but in linear flow of heat, steel material tends to have higher thermal conductivity than brass. So that's all from our group. Thank you.